Okay, so we've got a problem here. It's a math problem, a geometry problem, which is really a trigonometric problem. We're having a peek at it. It says a cruise ship traveling parallel to the shoreline turns 25 degrees to the right. It continues in this direction before making a sharp right-hand turn, so it is now pointing at a 10-degree angle to the shoreline. What is the measure in degrees of the second turn? That is not something you can do in your head, so we're going to do a drawing. So I can't draw very straight lines using my hand, so that's our shoreline. Imagine that's straight. And then let's draw our cruise ship. So we've got a little cruise ship. I'm going to make them this color. It's got a little cruise ship. Okay, it's very well illustrated. The cruise ship is going to, let's see what it told us, travel parallel to the shoreline. So let's say it's going this way. I'm really no good at straight lines. So that way, and then I don't really need the arrowhead. There we go. And then it says 25 degrees to the right. So what that's considering is that if you kept going, right, straight, it's going 25 degrees to the right off of that path. So we're talking about 25 degrees, so we're talking about kind of this way. So that angle is 25 degrees, okay? Now, we know something already about how this kind of area works. You see you've got 25 degrees there on this side of the line, and then this is a straight line, this is a straight line, so you know that this interior angle, that has to add up to 180. So 180 minus the 25, this angle has to be 155. Okay? So that's just from rules of trigonometry. Okay. Now it says makes sharp right hand turn, so it's pointing at a 10-degree angle to the shoreline. That second part I find kind of hard to decipher what they mean exactly, but I'll chalk it up to meaning this, and I'm imagining they mean 10 degrees from the shoreline, so this angle is 10 degrees off of the shoreline. I think that's what they mean. Obviously this is not to scale because this is not 10 degrees. And then they say, what's the measure in degrees of the second turn? So they kind of want this thing again, but here. So they say, what is that? And we're again considering, they're actually asking, what is this? So we are, oh no, this eraser's too big. We're considering the angle going from the initial path. So if it kept going straight, what's the angle that it turned right so that it's going this way? Okay. So this one's a little unique. It's a little special and kind of weird. You have to use a lot of trig rules. You can see we'd use the 180 is a straight line, because if you look at a circle, it's 360 degrees. So half of that has to be 180. So these have to add up to 180. We can do the same thing down here. So this angle is 170, because 170 plus 10 degrees is 180. And now we've almost, like, it's kind of looking like a triangle. Like if we made a line here, we could get a triangle. So why don't we do that? Let's make a nice dotted line, or a not so nice dotted line, all the way down. Now we've got a triangle, but the angles aren't the same. The new angle for our new triangle, I'll do it in a different color. Angle for this triangle and the angle for this triangle are different. Since we've cut a straight line down, it would be half of that angle. Obviously my drawing doesn't work out as nicely, but it should, or no, sorry, not half. We've drawn a straight line, not really, but we've imagined we have. So this should be 90 degrees. This, you know, this should be perpendicular with the shoreline. This should be perpendicular from the original path. So those are both 90 degrees, because they're the little square symbol. Okay, so minus 90 from each of those, and you'll get the one in our triangle. This is a lot kind of more complex than I would usually expect for grade 10 math. Or maybe it's not complex and I'm thinking using later stuff that you'll learn later, and that's why I'm screwing it up. Maybe there's a simpler way to do it. But that's what I'm getting. So there we go. So we've got those two angles inside our triangle. Now we can do a triangle must always add up to 180, all the angles. So now we can do 65 plus 80, 145, 180 minus 145. This angle here should be 35 degrees. Now we use once again that straight, like the semicircle law, if you want to call it that. 180 minus 35 is 145 degrees. So it should have turned 145 degrees to the right. I don't have an answer key. Michaela hopefully has the answer key. And I'm hoping it's maybe more simple than that, but that's just kind of how I solved it. So step by step, drew it out, always draw these out, and then I looked at the angle there, just kept solving for angles, and then made triangles, got rid of right angles to give me interior angles, 180 law, and then you can find that angle. So hopefully that works out. It may be a little overcomplicated. I'm pretty sure it's overcomplicated.